We are here today to discuss and review the simulation results and the technology. Here we go. Today's presentation is divided into three parts, namely part A, B, and C. In part A, we will discuss aims and objectives, introduction, and some highlights about the smart antenna technology. And in part B, we will briefly discuss the results which I obtained while simulating it in the MathCAD laboratory. And in part C, we will end up concluding with discussion of the results and future work. This is the outline of the presentation. First we will go through the introduction and then aims and objectives, and then we will discuss why we need smart antennas, what's the need for it, smart antenna classification, benefits of smart antenna technology, and this is very important part of the project, which is the technique which we developed during this project, which is the beam-free DOA estimation technique. And then we will just outline some of the important points regarding the adaptive algorithm, and then the simulation results, and then the conclusion and future work. Right? So let's discuss part A first of all. We will discuss here aims and objectives, and then we go to the introduction and then the beam-free technique. The aims and objectives of this project: to review the smart antennas as a wireless breakthrough for increased capacity and coverage, and then to investigate different types of adaptive algorithms, including the LMS algorithm, SMI algorithm, and the combination of both, which is mixed algorithm. And out of those algorithms which we have, we will select and simulate one of it in the MathCAD. The introduction. So historically, we use mobile communication mainly for voice communication. We use it for just transmitting our voice signals and communicating with others. In many countries, we have wireless communication more when compared to wired communication. Like most of the people are using wireless communication compared to the wired communication, and the landline communication is very few, very less. So, for using the mobile communication and for browsing the multimedia, technology, like to browse the internet and to browse music, to browse images while being mobile, we need greater capacity. The system should have more capacity and larger data rate, high data rate. But we all know that today's wireless communication systems are capacity limited. First of all, I would like to define the capacity. Capacity is defined as the total bit rate per unit bandwidth per unit area, and the units of the capacity is bits per second per hertz per meter square. So to increase the capacity of a mobile communication network, we go to smart antenna technology, which is one of the possible available options which we have now. Here are the fundamentals of antenna. Basically, an antenna can be as simple as a wire or a rod or a group of rods, which is used for not only radiating the electromagnetic energy but also to receive it. It serves as an eye of the communication system. Here's the antennas. We have omnidirectional antennas, which ideally radiate in all directions and receive energy from all directions. But this statement is not valid in practice, because somehow we will have directivity for omnidirectional as well. And we have sectorized antennas in which a large cell is actually subdivided into number of sectors, and each sector covers a part of the cell. Like we have sectorization in 60 degrees, 360, we can have 360 degree sectors, we can have 645 degree sectors, and so on. So big cell, a micro cell can be subdivided into subsectors, and in each sector we use different antennas to radiate the energy and to increase the directivity. So this technology, the conventional technology which we have for sectorized antennas, those antennas which will use to radiate more energy in the direction than required, in the direction where the user is not present. They will radiate energy in the directions of the envisaged user. So this will increase the probability of